Poskovich, that's it.
We'll take you care of your interfield.
Thanks. Well, some of you were here early, so I appreciate you all being here. Actually, BlueRidge Technologies, we're just up the street in Marietta, Georgia. We make our product here in Georgia, so if you're a Georgia contractor.
Yes.
So anyway, what I want to talk about is something we call unified lighting control. We went away from the term integrated because integrated can mean a lot of different things to different folks. But basically what we're talking about when it comes to lighting controls is basically bringing the two worlds together. And this graph is a little weak. I think it might be the monitor, so I'm going to switch to a more rudimentary graphic. Which basically, if you look at what's out there today in the market, standalone lighting control is the predominant choice that most customers end up with. Not because that's what they want, but that's because how it gets specified in Division 16. And there's some times where they actually want to try and integrate the two systems together, but in a lot of cases they're just adding another component called a gateway. Most of you that are contractors probably know that those just add cost, they add complexity. And in a lot of cases what happens is you end up doing a lot more work because you got to figure out who's going to win in a multi-master world. And that takes a lot more work for an integrator or a controls contractor. The other part of this is that we see in a lot of cases at the end of the job you still end up with two standalone systems because there's a lot of finger pointing and things like that that occur. So what we're talking about is something called the unified lighting control system approach, where we're actually trying to leverage the fact that we're building these systems on an open protocol. In this case we're going to use BACnet MSTP as an example. And the building automation system front end becomes the front end not only for the HVAC but also for the lighting. So we're bringing these two systems together, which is really the promise of BACnet in an open protocol world, is to bring these two systems together, not have to have multiple front ends, multiple pieces of software, and it streamlines what the owner sees on their end because their facilities folks only have to learn one system. They have to learn it, operate it, maintain it, and that's a significant investment when they have to retrain. The other benefit you get when you plug lighting control into a building automation system infrastructure is you get a lot of overhead for free. Basically, anything that the DDC industry has already solved, like IP connectivity, VPN, wireless. I saw a bunch of people running around here with iPads and Androids and talking about applications and things along those lines. So a lot of that stuff comes for free once you've plugged the lighting control system into that infrastructure. And if you think about where the lighting control industry is today, it's about where the DDC industry is about 15 or 20 years ago. Yeah, the technology is there in the lighting control world, but the contracting channel and the delivery mechanism to the user hasn't progressed like the DDC industry has. And in fact, a lot of the existing lighting control manufacturers offer you what we would call a proprietary implementation of their product, and they hand you a gateway and give you basically read points. And what we're talking about is something more sophisticated than that. Anybody seen any demand response programs here in Georgia yet? No?
Automated demand response?
Well, yeah, there may be some automated demand response, but most likely here in Georgia it may be just voluntary, where you actually just choose to shed your load based on what Georgia Power wants to offer you or something along those lines. I know that there's a few clients downtown that take advantage of that, but they've got large connected loads.
Are they offering any incentives to do that other than just the reducing your energy bill?
Yeah, it's negotiated pretty much here in Georgia from what I can tell. There's nothing formal yet. Well, the reason I'm talking to you about lighting controls is because I'm hoping that you're interested in getting beyond just being a DDC control guy and getting into what I call an energy management business. I think that's a more sustainable business for you if you're in the contracting side of this and traditionally been in the HVAC side. This is a pie chart by DOE. It's an aggregate of all buildings. If you look in the brochure I passed out, there's actually some detailed building types in there that you may touch. But regardless of what building type it is, lighting and HVAC, the combination of those two make up over 60% and in a lot of cases more than 70% of what's going on in the building when it comes down to energy consumption. So what front end does your customer perceive to be as energy management front end? Is it your system or is it somebody else's? And I think by adding lighting to your system, it becomes a much stronger message, a much stronger package, a much stronger solution for those customers. I'm going to talk a little bit about our product, and then I want to switch gears back to what I call some energy management strategies. So I'm just going to cruise through this. We've got a lot of different products. I've got one here with me today called a zone controller, distributed controller, that little box right there. But we also do backnet relay panels. Anywhere from 8 all the way up to 64 relays in a single panel. We do retrofit kits and retrofit interiors, which is if you walk into an existing building and they happen to have made the mistake of buying a competitor's product in the past, we forgive them. We just give them a path to migrate off of that old standalone product and integrate it into the building automation system. And of course, what we call zone control is this device here in the bottom right-hand corner. Also got a number of field devices, but in general, we try to be as open as possible on the field device side, so you don't have to use our aux sensors or any of our switches. You can use pretty much anybody's sensor or switch or photocell that you desire. It's more of a universal input take rather than something very proprietary. This is an example architecture of our zone controller. You can see here's the zone controller, resides on the BACnet MSTP network. You can also mix that with the relay panels and anything along those lines. They're all BACnet MSTP native. We offer a switching or a dimming module. So if in Georgia now we're starting to see more, the energy code is starting to require more daylight harvesting, and there's a trend towards dimming in those applications because of disruption to the environment that they're going in. On the module themselves, they're universal inputs. In this case, we've got 6 universal inputs on this particular module. And then you can expand it with what we call a subnet, the satellite and station network. So you can basically put point expanders. That's what a satellite is. It allows you to add additional I/O, whether it's relays or inputs or analog outputs for dimming. Several different versions of the controller that we offer, the switching versions and the dimming versions. You can see the size there, it's fairly compact. The idea here is that when you walk into an existing building, there's an awful lot of existing circuiting and things that already occurred in the past. And when you go above the wall switches, there's typically a 4 square or 411/16 J-box above the wall switch location. What you basically do is pull the cover off of that J-box and you mount the zone controller to that. When you mount the zone controller to that, it also separates your line voltage and low voltage compartments. And here is your line voltage section. Here's your low voltage section. In that line voltage section, coming to that J-box is a hot, neutral, and ground, whether it's 120 or 277. Those wires would basically get re-terminated on the appropriate terminals here, which powers up the relays in the module, but we also steal power for the controller as well. Out of the junction box would have been 2 wires going out for the inboard outboard in this particular example, and those would get terminated to the 2 terminals on the relays, 1 and 2. And the 2 line voltage switches that were down the wall that are coming back up, those would get terminated as line voltage switch inputs on the controller. No need to rewire those or try to go wireless, so this is my version of a wireless retrofit solution. So that's the line voltage section. And then once you've made those line voltage connections, the only other thing you really need to implement control strategies is a BACnet MSTP network over to that device, which allows you then to basically take schedule control. These switches are fully programmable, just like a regular low voltage switch input might be, so you can use it as a timer switch after hours, so on and so forth. On the low voltage side, there's 6 universal inputs. We can also supply up to 100 milliamps of power for occupancy sensors and things along those lines. These can also be configured as 0 to 5, 0 to 10, or 4 to 20 milliamp. On the analog outputs, those are designed for the 0 to 10 volt dimming ballast, and I'll talk a little bit more about that in the rest of my presentation about the dimming ballast technologies and what's out there. And then on the controller board itself, we offer micro USB, so there's no custom cables required. You use your own micro USB cable. If you do choose to, we also offer a Bluetooth option, so you can program the unit from the ground rather than having to get up in the ceiling and attach to it during the commissioning process. So those are some of the highlights I wanted to cover on the zone controller. Any questions before we switch gears to? Okay. I'm going to go into energy management strategies. When you're out there looking at potential savings for lighting controls, you'll hear a lot of, hey, we can save you up to 70% of your lighting energy, we can save you up to 50% of your lighting energy. I'm going to walk you through some of those storylines. But where most of your savings is going to come from is controlling the bookends of that facility. I don't care what kind of facility it is, that's where the savings comes from. Roughly 50%, there's another 8% or so you can grab by implementing a control strategy we call manual on. Rather than turning the lights on in anticipation of people coming into the space in advance of them getting there, let's do it like the old days, right? When you walked into the room, what'd you do? You went and flipped the switch. So when you implement that kind of control strategy, you can save some additional hours in the morning, typically, somewhere in the neighborhood of around 2 hours, which is what we have factored in here. If you use 8 cents a kilowatt hour and you look at this chart, basically you're looking at about $500 in savings annually. Okay, now that's assuming you're running the lights full blast, but if you get into baseline analysis and things like that, it gets a lot more complex, so we're just going off of a very simple approach here. When we look at a control strategy that takes care of this, what I'm trying to do is combine the building automation control system with the lighting control system. So what you'll see is here, I'm leveraging what the BAS schedule is, what its status is. When the system goes occupied in the morning, we disable the timer function on the local override switch. We didn't turn any lights on in this particular case. I might have had areas of egress in the building that we decided to turn on, but in this particular space, because it is a private office or a conference room or whatever, we decided not to turn the lights on before people got there. When the person got there, they flipped the switch and turned those lights on. We also use that as a signal to say, hey, let's go out of reset minimum on temperature and ventilation, go up to set point and full. Now, when they left early, because there's no aux sensor in this particular scenario, remember I'm controlling the bookends, there's no aux sensor in this particular scenario, I'll show you one in a minute that will have one. We don't capture all the savings there. But at night, when the building automation system goes unoccupied, we enable the timers and we shut off the lights. We also implement what we call a blink warning function. So the lights will blink essentially before the occupants go and get put into the dark. They'll have about 10 minutes roughly to get up out of their chair and go hit the override switch or pack up their bags and head on out. The nice thing about this is there's basically one schedule to maintain. And I know we do a lot of K through 12 schools. There's somebody usually doing scheduling in those applications, and it can get complex. So having one place to go to do the schedule would be nice. The other thing you got to think about when you walk into an existing building is that the circuits already exist where they are. And what I see in a lot of cases is you might walk into an owner and say, hey, they're looking at doing lighting controls, you give them a price and it's maybe relay panel centric, and they say, well, I want to get these zones divided up into more areas, I want to be able to control them separately. Well, that's difficult to do without a lot of rewiring. Things are changing along those lines, so I'm going to show you a couple of different examples. So this is the solutions we've had for a long time, which is you basically put a relay panel, one or multiple relays back in the electrical closet, tied to a backnet schedule, and then either in this case put in a telephone override, or in this case put in a after hours override switch that may be strategically placed so that when that blink function occurs, they know where to go to. And the line voltage switches basically would stay in place just as they are, so that during the day they had normal operating conditions. I call this kind of a poor man's energy management system, but there's an awful lot of customers that will buy this because it fits their need, and their need is to control the bookends. If you want to go beyond that, and you do want to have more finite control of those areas, maybe different schedules, because that area at the top there might be the accounting department, and we know that 6 months out of the year they're running a completely different schedule than they are the rest of the year. So we'd like to be able to separate them out of the rest of the area and control them differently than these other spaces. So in that case, the zone controller would go in and you'd have the ability to use the line voltage switch as your after hours override as well. So there's really no new wires basically getting pulled in that scenario from a control standpoint. So those are kind of the options for controlling the bookends. When we add in vacancy detection, in this case we're going to try and grab 3 additional hours, so we go from $500 to $560, an additional $60 in savings in this particular case. You can see that the sequence, I've given you the same 4 slices you saw before. We have occupied, 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 unoccupied. When we went occupied in the morning, we also took the aux sensor and basically bumped up its timer value. There's a lot of customers I run into that have installed occupancy sensors, and their biggest complaint is somebody has to do jumping jacks all day long to keep the lights on, right? That's no fun. So to help minimize complaints or eliminate those complaints, you can automatically, based on the status of the building, occupied or unoccupied, change the timer value that's associated with that sequence. So in this case we bumped it up to 30 minutes. You'll notice at night we went down to 10 minutes. The other thing we did was we actually implemented what we call a manual on control strategy, right? We saw that before. I'm continuing that control strategy in this scenario. Even though the aux sensor picked up that occupant, it doesn't automatically turn on those lights. It'll actually require the switch to turn those lights on. The other thing we did is we get more positive confirmation that somebody's in that space so that we can actually deal with the change from reset minimum up to set point and full on the HVAC side. And then when they left that space, after that timer ticks down, the 30-minute timer on the aux sensor ticks down, the lights would also go off, and you'd also be able to go back to reset minimum potentially on your temperature and ventilation. The nice thing about this is that aux sensor value becomes a system value. No longer do you have to walk in there with a ladder and a screwdriver or a dip switch setting on that aux sensor. That 30-minute or 10-minute timer is a parameter now. It's an analog value within the building automation front end that can be adjusted. Here's what the infrastructure would look like if you were going to do occupancy sensors. So this is the traditional approach, standalone occupancy sensors, where you have a sensing head, a relay / power pack, and then you've got your line voltage switch. In that particular scenario, it's difficult to implement a manual on control strategy because the minute you flip the line voltage switch to the on position, the aux sensor will turn the lights on and off, basically as the occupancy changes status. In this case, over here in zone control, my switch is basically a smart switch now, and I can require them to come back and flip that switch back on. The other thing that we've done in our controller, I'll talk a little bit about, is that we've implemented what we call a grace period. So if you implement the manual on control strategy within our controller, the grace period can be enabled so that if for some reason the aux sensor did turn the lights off on the occupant falsely and they wave their hands to get the lights back on, that would be a true condition for a minute, that they could actually wave their hands to get the lights back on automatically, even though you were in a manual on control strategy, just for that short time period. Some of you may also have considered using one of your HVAC controllers that has a spare digital input on it to pick up the aux sensor status, right? That's another choice you have, right? If you're a DDC control guy and you happen to have a distributed HVAC controller nearby that, say, classroom or wherever, you may try to pick up that aux sensor, and that clearly is a choice. But I want to share some thoughts with you. One is, down here at the bottom, verification of that particular sensor and relay. In our case, we'll give you both the sensor and the relay status. In this particular scenario, all you're picking up, unless you grab the relay status or have a relay that can provide you with status, is that you're picking up basically the occupancy sensor only. In addition to that, the timer value is still down here at the occupancy sensor head. It's not up here in the system. So there's some different things that you got to think about there. We talked a little bit about reducing complaints because the timer is managed by the BAS. It can be modified easily. The manual on eliminates the false off or false ons by walk by, and then this grace period we've already talked about. The other nice thing is that you can start to implement more advanced control strategies, kind of like I described in the PowerPoint slide there. I know the industry is moving towards LEDs. I saw some out here as retrofits for fluorescent fixtures, but there's still an awful lot of customers out there that have fluorescent tube lights in their building. And if you're not educated, you're going to get a little education here this morning on ballast and what that means when you start to control the lights. Most fixtures out there that have been shipping for a while have what they call an instant start ballast. It's the most economical ballast, meaning it's the cheapest when they bought the fixture originally, and it's also the one that's the most energy efficient. It consumes the least amount of energy. Okay, so that's normally the fixture most people buy. The problem with that is that when you start adding, say, occupancy sensors to that, the life of those lamps is dramatically reduced. This is not the case when you go to LEDs, but if you have fluorescence. So I've seen a lot of customers that have decided to go down, say, the occupancy sensor path and put occupancy sensors in their buildings, not realizing that all of their fixtures are instant start ballasted fixtures, and all of a sudden they start complaining about poor lamp life. Well, no wonder, because the lamp life, the rating on that lamp life is basically at or around where you get 12 hours of continuous operation on that lamp. So that 20 to 30,000 amp rating, or 20 to 30,000 hour rating on that lamp is there because you run it for 12 hours constantly, right? If you start to reduce the hours per start, so this is 3 hours, this is 1 hour, this is 30 minutes, this is 15 minutes. And you can see this is the lamp life in hours here. It gets dramatically reduced. So we're starting to see more sophisticated control strategies to where when the aux sensor turns the lights on initially, if it were to do that the lights wouldn't go off for, say, 2 hours minimum, that they would stay on. And then after that, they might start to cycle more often. So there are some different control strategies. If you pay out of pocket for what they call spot relamping, it can get expensive. According to DOE, it's about $9 per lamp to essentially do spot relamping. If you're not familiar with that term, it's basically when that lamp goes out in that fixture, the guy comes in here, pulls out that lamp, puts in a new lamp. The other strategy is what they call group relamping. You monitor the life cycle of your lamps, and then when most of the lamps reach that point of failure, you say, all right, we're going to pull the trigger and just relamp everybody rather than waiting for it to fail. I've seen a lot of school districts that take it not as a $9 hit in their pocket, but as an efficiency hit to their operational group, because it's kind of a hidden cost to them. If you think about a typical classroom, if it's got fluorescent lighting, it's got roughly 12 fixtures in there, 3 lamps per fixture, that's 36 lamps. How many times before the facility guy walks into that classroom and says, maybe I should just replace all these so I don't have to keep coming back here. So those are the kinds of scenarios that start to lead you into what we call equipment optimization with lighting controls, which really hasn't been something that's done traditionally. You guys may be used to that on the HVAC side, but it's not something that's done well or done at all really on the lighting control side. The other thing we can roll into the control strategy is what we call level control or daylight harvesting. This is actually giving you the ability to control the level of the lights during the day. And it can be very basic, or it could be relatively advanced. In this particular scenario, we're going to take about 7 hours of the day and we're going to reduce the lights about a third roughly. And this is how you get up to your 80% energy savings. And you may hear that term from other lighting control folks who compete against us. But one thing that I'll tell you is you start looking at this particular chart here, and most of the savings is coming from the bookends. And as you get into the middle of the day, not only are those savings less, but they're harder to reach. So your ROI starts to get extended. I've seen daylight harvesting systems that have been proposed in the 15 to 20 year payback range. And not a lot of customers buying that. So if you ever have a customer who says, or you know them pretty well, and they say, no, we got to have a 3-4 year payback on our energy programs, and all of a sudden they start saying, well, I also want to do daylight harvesting, well, you probably need to have a conversation with that customer about what the expectations are when it comes to daylight harvesting. I'll show you a couple of choices you have related to that. The first choice you have when it comes to level control or daylight harvesting is the choice of the fixture or the ballast that you're going to control. And with the traditional approach, what I call bi-level control, you walk in the room and there's 2 switches and you have the outboard lamps and the inboard lamps. That's what you'd see here, right? So if I were going to do daylight harvesting with that particular application, I would shut off maybe the inboard lamp. So one lamp is going to be dark, right? And when the lamps are dark, if the occupants of that space don't exactly know what's going on, they might be picking up the phone and calling maintenance and then calling you saying, hey, something's wrong, something's not working. So in a lot of cases, we've seen that. This control strategy has been around for years for daylight harvesting. It got implemented, I saw it a lot in K through 12 in schools. And of course, the first thing that happens is the teacher calls the maintenance guys and they say, well, okay, we'll come and fix it. And their idea of fixing it is basically bypassing. So they just paid for all this nice daylight harvesting equipment, and you got a system that's been bypassed, because they didn't understand what was going on. In this particular scenario, this is a little better because you're talking about a step dimming ballast. Still requires 2 relays. So if one relay's on, you're at 50%. If both the relays are on, it's at 100%. And if both relays are off, the lights are off. The good news here is that whether it's a 2-lamp or a 3-lamp ballast, all the lamps are illuminated at the same level. So there's no dark lamps anymore. So we're starting to see a trend in this direction. The other nice thing is you do have the capabilities of basically doing a what I call a switching daylight harvesting, where the lights kind of look like they're at a dimmed level rather than switching lights in and out. The other choice is what we call a 0 to 10 volt ballast, a dimming ballast. So this thing would allow you to dim the lights all the way from, say, 100% all the way down to a low level, typically around 5 or 10% is the low end on these. The reason they cap the low end is so that they can offer it at an energy management price. If you've ever gone out and tried to buy a dimming ballast, a lot of them are architectural ballasts, and those are fairly hefty on the premium. To go to a dimming ballast, it can be somewhere in the neighborhood of $100 to $150 to do a dimming ballast. So if you start adding up how much you can save, and you can see how they could get extended quite quickly. But the 0 to 10 volt dimming ballast is starting to become the energy management ballast, and we're starting to see the price point of that ballast come down to where now it may be maybe a $30 to $50 adder over a standard ballast, rather than what it used to be, like $100 or $150. So this is changing, and it's getting a lot more economical to do 0 to 10 volt, but you're still going to see a relatively long payback when you do dimming daylight harvesting. Okay. The other nice feature that you can do with the dimming ballast is you can actually do task tuning or lumen maintenance on it. And if you're not familiar with those terms, just like HVAC, right? When they design the system, they got to have excess capacity to account for all kinds of things. We call it in the lighting world basically lumen depreciation. So as those fixtures get dirtier and the lamps wear out and the ballast gets less efficient, that it still will maintain a good foot candle level in that space. So there's some over design in every lighting job that goes out there, because you got to have it initially, right? So what you can do for the first year or so is tune that out of the system. You can basically cap the top end in this particular scenario. The other thing you can do is set a load limit, load shed load limit. So in some cases we've implemented load shedding strategies, and they didn't want the lights to go below a certain level. It also allows you then to actually go query the system and see how much is available to shed, because now you know what your bottom end is. So in level control, you'll notice that in this case I'm using the bi-level scenario, so that middle lamp is is out right now. There's not a lot of impact to HVAC. I just left that flat. If you were to do 0 to 10 volt or even the step dimming ballast and you were trying to do daylight harvesting, that's what it would look like, or level control. So as you start to look at this, one of the things you're probably going to notice right away is the point density is increasing dramatically. And what's happening is, if you think about DDC control, right, it started out as unitary and went down to the zone. Lighting control started out as centralized relay panels back in the electrical closet, and now it's moving out to the zone as well. So the same transformation that you saw in DDC controls is happening with lighting. And the reason for that is the energy code is starting to drive more sophisticated controls. Before it was, you just had to shut the lights off, right? And it had to do it automatically. Then it was, now you have to shut the lights off automatically, and you need some form of after hours override that can't exceed more than 2 hours. Okay, well that's can't really do with contactors and time clocks and timer switches anymore. And then now they're starting to require you to do what we call light reduction. You have to be able to affect the level of light in the space, because there's a lot of studies that have shown if you give people control of their lights, they'll use them more efficiently than if you just give them a, lights are on or lights are off. The other scenario is we're starting to see the requirement for daylight harvesting. They're not telling you how to do it. They're not saying you have to do dimming or switching or anything like that. They're just saying that in spaces where you have a skylight or windows, that area within the building has to be controlled separately from the general illumination. So you start thinking about a classroom. You got potentially inboard, outboard lights in a classroom. You have the daylighting set of lights near the window. In a lot of cases, we're starting to see teaching wall or teacher lights. So there's 4 relays. You got an occupancy sensor. You got a photocell. Right? You start looking at the point density. It doesn't make any economic sense to do that as a centralized relay panel. So that's driving the trend in our industry as well towards distributed controls. The other thing that we've done on our controller is we've given you two control strategies. One is the traditional daylight harvesting, where there's a set point that you would adjust basically through the backnet side of the world. You go in and calibrate that, and it's a fairly intensive commissioning process to go through. But we said, there's probably a better way to do this, which is let's let the occupant choose the set point, just like they might do in temperature control. We just happen to give them we allow them to basically set their lights wherever they want, within the ranges that I talked about earlier, if it's dimming fixture, right? So in this case, you'll see that the occupant comes in and they're going to do a computer-based task. And let's say that this is in the morning. So they decide they want their lights a little bit lower. Well, I'm capturing manual control savings, but I'm still also going to capture the daylight harvesting savings in that application as well. Okay, they went to lunch, they came back, they said, oh, okay, I got to look at plans this afternoon. I need my lights to be a little bit higher. And we have less manual control savings, and we still get the daylight harvesting savings. So it's more of a user-centered application and doesn't require as much commissioning during that process. And again, you can see here's the different bi-level ballast. This has everything: light sensor, aux sensor, wall switches, 2 relays. Basically, the exact same infrastructure is required for step ballasts. And then over here, when you get into dimming ballast, you'll need a way to basically dim those lights up and down. So I've added in our raised lower stations for that. Here's the 0 to 10 volt purple and gray wire that comes back. So that's a low voltage analog signal that has to come back to the controller. So there's a lot of choices to make when you start thinking about controls and control strategies. So what we typically like to do with a customer or an owner is start at a space. And what you'll find is if you look at a particular building, there are 5 or 6 common control strategies that you can develop, what we call them energy management strategies. And once you know how you want the lights to operate in that space by themselves or in conjunction with the HVAC, then you can write that sequence, and then you can determine what you need to implement that. And we can help you with that. So when you look at the chart here, we got all the way up to $600 in savings. Some easier to get to, some less easy to get to. But in general, what you'll find is that lighting control, bookend control, manual on, vacancy detection, those we can typically get in the 3-year and less time frame, even with the Georgia power rates that we have around here. The other areas might be more difficult depending on the technology you use to get to those. When I look at applications out there, if it's new construction, they're probably on lighting control, if they're meeting the energy code requirements, probably around $1 in total install cost with everything is probably around $1.50 to $2 a square foot. I've seen retrofits as low as 39 cents a square foot, so it's kind of all over the ballpark there. And I've seen gold-plated stuff all the way up to $6 or $8 a square foot. So there's quite a range when it comes to lighting controls, and it really depends on what they're trying to drive at. So I'm going to switch gears now, and we'll talk a little bit about the demo unit I have here. Can everybody see this all right? So this module mounts to, like I said, a 4-square junction box. Once you've done that, the line voltage compartment is here, and that's where the wires come through, or you can see my fingers here. That's where the wires come through for the line voltage section. That's the terminal block that I showed you on the PowerPoint earlier for the line, neutral, ground, the 2 switches. So these are 2 Decora style line voltage wall switches. Nothing special. That's turning the lights on and off. I also have an addressable station here, and that they have pilot lights on them or indicators. In the energy code, if you have a switch that's a master switch or remote from the space and you're not in the space to see the lights, you also have to have annunciation on the switch. So those are the kinds of things you got to think about when you're trying to meet the energy code. This happens to be an occupancy sensor. I'm not going to wait around for it to time out, but that's basically what we have in this module. If you want to come out, I'll show you how it actually operates in a little more detail. This is a dimming photocell so that you can actually see what the light level is in the space, and we can implement a dimming control strategy, and I've got software in that over there if you want to come over and take a look at it. This is the low voltage section, so you can see here I've got 6 universal inputs. I'm actually powering up this aux sensor out of that UI, so that's 24 volts DC going to that occupancy sensor. No power pack, no nothing else, right? Here's the controller board. You set your basically your back net baud rate here on the dip switch. Your MAC address is set there. This happens to be what we call an optional. This is the optional Bluetooth radio. So if you didn't order it with the Bluetooth on it, you could add that at a later date. What that does is basically allow your technician to program the system from the ground. It also allows you, once you've made this connection to this module, anything else on the MSTP bus that's one of our devices could be seen through that port, so it's tunneling basically through there. This is the micro USB port right here. The controller board itself has a power cycle switch, so when you change dip switch settings or MAC addresses, you typically have to power things down, and instead of having to go find the circuit breaker to do that, just try to make it a little easier for you. So that's pretty much it in a nutshell for that little device. So, thanks. Any other questions? Anybody want to do lighting controls? We're planning on putting together a training session with Stromquist for you guys. Anybody who wants to participate in that, get in touch with somebody. We're up at Stromquist here, and we'll get you in that class if you're interested in doing it.
If you need to control it or measure it, Stromquist & Company has a control solution for you. With over $2 million of inventory between our Georgia and Florida locations, an easy-to-use online ordering platform, same-day shipping, and a factory-trained team of controls experts to answer your questions, Stromquist & Company continues in its tradition of offering great service and great products.